Welcome to qnawire.
In this problem, we have the statement that the absolute value of x is equal to the square root of x squared. So let's use that idea to find the derivative of the absolute value of x. So that would be equal to the derivative of the square root of x squared. And we can use the chain rule on that. So the square root function is the outside function, and its derivative, if we think of it as a 1/2 power, would be 1/2 times the inside to the negative 1/2. And then we multiply by the derivative of the inside. So we have the derivative of the outside times the derivative of the inside. And we can simplify that. We can multiply the 1/2 and the 2x together, and that gives us x. And then we can take the part that's to the negative 1/2 power, bring it down to the denominator, and change it back to a square root. So then, if we substitute the absolute value of x in for the square root of x squared, we end up with x over the absolute value of x. That's the derivative of the absolute value of x. And that was what we set out to show. Now we can apply that to a couple of problems. So we have part B, where our function is the absolute value of the sine of x. So it's not just the absolute value of x, it's the absolute value of the sine of x. So we're going to be using the chain rule along with this derivative that we just found. So what we'll do is the derivative of the outside would be the function over the absolute value of the function multiplied by the derivative of the inside. So the derivative of sine is cosine. Okay, now we're going to graph that. We're going to graph the function and its derivative and see what we think of what we see. So we go to the calculator, we go to y equals, and we type in our functions. F of x equals the absolute value of sine of x, and then its derivative. And for a window, I chose to go from, roughly negative 2 pi or so, a little bit more, maybe around negative 3 pi. Somewhere in there, it doesn't matter. We could change these. We could make it negative 2 pi to 2 pi. And then the y values, negative 3 to 3. And we can press graph. Okay, so first of all, let's turn off the derivative function and let's just look at the original function. Do you see why that would represent the absolute value of the sine function? The sine function normally has this curve, but then it normally goes down here. However, because we took the absolute value, it flipped all the negative parts up to the top. Anything that was below the x-axis, it flipped it upside down. So we just have all of these curves above the x-axis. And so for the derivatives, let's turn that derivative equation back on. Notice we have all these separate segments. The derivative is not defined at 0. It's not defined at pi. It's not defined at 2 pi, at negative pi, at negative 2 pi. It's not defined at any multiple of pi. So we'll say it's not defined at n times pi, where n is an integer. Now let's go ahead and do part C. So we're back to finding the derivative of a function. And this time our function is g of x, and it's the sine of the absolute value of x. So we're using the same two functions, but in a different order. We're still going to need to use the chain rule to find the derivative. So the derivative of sine is cosine. So the derivative of the outside function is the cosine of absolute value of x. And then we multiply by the derivative of the inside function, and that's where we get the x over the absolute value of x. So let's go ahead and take a look at the graph of that as well. All right, so back to the calculator and back to y equals. So here we have typed in the original function g of x and its derivative g prime of x. Now I only have the original function y1 turned on for the moment, so let's take a look at its graph. So what happened was we took the cosine graph, actually the sine graph, excuse me, and we took the right side and it ended up reflected across to the left side because we took the absolute value of x. So any x value that was negative ends up having the same y value as the corresponding x value that was positive. Okay, so then let's turn on the derivative graph. And it's the red one. So it's defined everywhere except at x equals 0. And that's because if you think back about what we had a denominator of absolute value of x, and right over here, and so we can't divide by 0. Everything else was defined. So there we have it.